Hi everyone. In this video, we're going to be analyzing another physics graph, and this one is going to be related to static and kinetic friction. So this is a problem from the 2023 June Physics Regents, and it says, a student pulls a block weighing 2.0 newtons, resting on a horizontal laboratory table, with a string and a force sensor. The sensor measures the force applied to the block when the block is at rest and when the block is moving. The force applied to the block is plotted against time on the graph. Basically what's happening is someone's pulling on this block and trying to get it to start moving, and for the first 2 seconds they're not pulling hard enough. So 0.1 newtons is not strong enough to set the block in motion, and 0.2 newtons is not strong enough. They keep going with more and more force until they get to 1.0 newtons, and then finally that's when the block starts to move. A force sensor is similar to a spring scale, it just measures how much force is being used. So I started by annotating and I circled the number that they gave me, 2.0 newtons. And because it says that the block is weighing 2.0 newtons, I wrote down Fg equals 2.0 newtons. That's because Fg is the same thing as weight. I also know that the normal force, or Fn, is 2.0 newtons because the block is on a horizontal surface, so those two are always going to be equal. Then I boxed some keywords. I boxed force applied because this tells me that this force on the y-axis of my graph is an applied force. It's also going to be equal to the force of friction because the block is either not moving in this section or it's moving at a constant velocity in this section. So the applied force that's recorded here is always going to be the same as the force of friction. So we'll be using those interchangeably for this problem. I also put a box around rest because in the first section we're at rest, and then moving because starting from here we're moving. Question 81 says, based on the graph, determine the force of kinetic friction acting on the block as it is pulled at a constant velocity across the laboratory table. I'm solving for force of kinetic friction, so I'm writing FF equals question mark. Constant velocity is always a really important keyword, so I put a box around that. That tells me that I'm looking at this section of the graph, this horizontal line. And that tells me that the force is 0.9 newtons. If I'm looking at this section of the graph, they just want the force that's given to me. I can just look it up right on the graph. I don't have to do a calculation for this. Moving on to question 82 and 83, it says calculate the coefficient of kinetic friction between the block and the laboratory table. So these are the three values that I know. I'm supposed to be looking for coefficient of friction, or coefficient of kinetic friction. So I wrote mu equals question mark. Kinetic is important because, again, that shows that we're looking right here at this section of the graph, and that just kind of confirms for me that force of friction is 0.9 newtons. I already wrote that down, but that word helps me be sure about that. So this is the formula that I picked. FF equals mu Fn, and that's a good formula to use because it has to have mu since that's what I'm looking for. And FF and Fn are both values that I already know. So since I'm solving for mu, I wanted to put it in the triangle to try to rearrange it, because it's going to be easier if I have something that starts with mu equals. So to put this in the triangle, I put FF on top. Sometimes if there's a fraction over here, you would put whatever's in the numerator on the top of the fraction, in the top of the pyramid. But since there is no fraction, you're just whatever's by itself. FF goes on the top, and then mu and Fn. And the way I use this is I just cover up mu, and I see that mu is equal to FF divided by Fn. So that's my formula I'm going to use. Now I can plug in my numbers. Mu equals 0.9 divided by 2, and I just got those from right over here where I listed them out. When I put that into my calculator, I get mu equals 0.45. No units for this. Mu never has any units. So that's my answer. Question 84 says, at the instant the block begins to move, what happens to the value of the coefficient of friction? Let me annotate. Begins to move is kind of the key word here. And when they say what happens to the value of the coefficient of friction, that just means they want an answer that is either it gets bigger, it gets smaller, or it stays the same. So I don't have to say anything too specific. I don't have to give a number or calculate anything. I just have to explain whether it would increase, decrease, or stay the same. And instead of looking at the graph, I think it might be easier to just look at this approximate coefficients of friction table that we have on our reference guide. That's because when the block begins to move, it's changing from static to kinetic. And every time you change from static to kinetic, the coefficient of friction goes down. That's a universal rule. It's not just for these specific materials. It doesn't matter what the materials are made of in this particular problem. When you go from static to kinetic, it will always follow that trend, so it's going to decrease. That is all you have to write down for your answer. It decreases. Feel free to put an explanation, but technically the question didn't ask you for it, so it decreases would get full credit for this. And question 85 says, how would the coefficient of kinetic friction between the block and the laboratory table be affected if a 0.5 kilogram mass were placed on the block? I started by annotating. I underlined how would the coefficient of kinetic friction be affected, because that's kind of what the question is asking me. Once again, they just want to hear increase, decrease, or stay the same. They don't really need me to do a calculation. But they did give me a number, 0.50 kilogram, and that is a mass. So I started by writing this formula because I think this might be something that is a common misconception. So you might want to use this formula to see what would happen if I changed the mass. If I added more mass, that would affect my normal force. It would be a bigger normal force. And that might make you think that the coefficient of friction will be affected in some way. However, it's important to remember that the coefficients of friction are really just determined by the two materials. Rubber on concrete is always going to be 0.68 or 0.90 for kinetic or static. It doesn't depend on anything besides those two materials. So this is another fact. Coefficient of friction depends only on the two materials. In that case, it is not going to be affected if we add in mass.